This is going to be our video for Unit 3, Day 9. So what we're doing today is optimization. So with quadratics, we also call this finding the vertex. So whenever we find the maximum or minimum value, that's what optimization is. That's what that word means. Finding a maximum or minimum value. So with a quadratic function, that maximum or minimum point is called the vertex. So when we say optimization or find the vertex with a quadratic function, that means the same thing. So just like when we're solving a quadratic equation, if we're going to optimize, we're going to find the vertex, find the max or min, we have to start in standard form. Alright, so standard form for a quadratic function is different than an equation. It's not equal to 0, it's y equals. And then we still have our descending order, ax squared plus bx plus c. Now we find the vertex, right? The vertex is a point. Alright, so it has an x and a y coordinate. We have to find both or we haven't found it. To find the x coordinate, we have a formula. Alright, to find the x coordinate, take the opposite of b and divide it by 2a. Again, those a and b, they come from the standard form. That's why we want to start in standard form. Alright, and one other thing with the opposite of b, that doesn't mean it's always negative. If b, the number itself, is negative, opposite of b would be a positive number. Alright, so we use the formula to find the x coordinate, but to find the y coordinate, we're going to have to substitute our x value back in. And then put it through the function to find out what the y value is. So substitute, remember, is another word that means plug in. So we'll do two of these example problems here so you can get an idea of what this looks like. So find the vertex of each quadratic function. So the first one, see, it's already in standard form. I can look at it and tell you that a is negative 2, b is 20, and c is negative 5. Alright, for the vertex, we don't have to use c. We really just need a and b. Alright, so to find the vertex, I'm going to use that formula for the x coordinate. Negative b over 2a. Alright, in this case, b is 20, so that's negative 20 over 2, and a is negative 2, so it'll be 2 times negative 2. So that'd be a negative 20 over negative 4, which would be 5. Alright, so I know my x coordinate is 5. So to find the y, what I have to do is plug 5 into the function. So I'm going to have y equals negative 2, 5 squared, 20 times 5 minus 5. Alright, so we take this original function, and we're going to plug 5 in. So make sure we follow order of operations when we do this. We have to square first. So negative 2 times 25, 20 times 5 minus 5. Negative 2 times 25 would be a negative 50. 20 times 5 is 100 minus 5. So I'll have 50 minus 5, which is 45. So I want to make sure we write it as an ordered pair, the vertex for this one. would be 5, comma 45. So both the x and y are part of the answer. So the second example we'll do is going to be the same idea. Again, this one's already in standard form. I can look at it, say that a is 1, b is a negative 24, and c is 8. Right, so find the vertex. I'm going to start with that formula, negative b over 2a. Alright, here b is already negative, so opposite of negative 24 would be a positive 24. And a is 1. So I have 24 divided by 2 will be 12. So I have the x coordinate of 12, so I can even start to write the ordered pair, 12 comma something. That's going to be my final answer. Now to find the y value, I'm going to plug the 12 in for x. So that 12 squared would be 144 minus 24 times 12, 288 plus 8. Alright, now do subtraction and addition, so 144 minus 288 would be a negative 144 plus 8 would make a negative 136. That would be our vertex. So here's some practice problems. There's 6 problems there for you to practice on your own and get the hang of find this vertex on your own. The other thing we need to talk about is once we find it, we know that the vertex is the maximum or minimum value. How do we know which one it is? So the way we tell if it's max or minimum is that number a, the leading coefficient. Alright, that number tells you whether it's a maximum or minimum. If a is positive, alright, the picture of the graph opens up, which makes the vertex a minimum. Alright, so it would look something like this. That would be an example of a graph that opens up. Our vertex is a minimum since the graph is opening up. The other case, if a is negative, that leading coefficient is negative, the graph opens down, and the vertex is in a maximum. Right, so what that would look like is something like this. Would be an example. This point right here at the top would be the vertex. It would be a maximum. So for practice, what we're going to do is go back to those 2 examples on the last page. We found the vertex, and we're just going to say whether that vertex is a maximum or a minimum. So if you look at the first one we did in green, that leading coefficient a was negative, which means the graph opens down. Since the graph opens down, that means this vertex is a maximum. On the other hand, we look at our second one in blue, leading coefficient a is positive 1. Right, so if it's positive, it means the graph opens up, vertex is a minimum. So that's it for this set of notes. This is something that you need to get very comfortable with doing, get some practice with. So we're going to use this for what we're doing tomorrow, which is going to be actually taking this vertex and using it to start the graph of the whole function.